Imagine you're holding an apple and it slips from your hand. What happens? It falls to the ground. But have you ever wondered why? The answer lies in an invisible force we experience every day: gravity. Gravity, it's this mysterious and unseen force that governs not only our daily lives but the very fabric of our universe. It's the reason why we don't float off into space and why the Earth orbits around the sun. But what exactly is gravity? In essence, gravity is a fundamental force of attraction. It's the glue that binds together the universe, keeping our feet firmly on the ground and the planets in their orbits. Every object that has mass also has gravity. The more massive an object is, the stronger its gravitational pull. This explains why you're not drawn to your coffee mug, but you're firmly held by the earth beneath your feet. The concept of mass plays a crucial role in our understanding of gravity. Mass is the amount of matter in an object, and it's this mass that gravity acts upon. The greater the mass, the greater the gravitational force. So an elephant experiences a stronger pull than a mouse, and a planet like Jupiter, with its immense mass, has a much stronger gravitational pull than our own planet Earth. But gravity isn't just about keeping us anchored to the Earth's surface. It's also the driving force behind celestial mechanics, the study of the movements of celestial bodies. It's gravity that keeps the moon in orbit around the Earth and the Earth in orbit around the sun. It's gravity that pulls together clouds of dust and gas to form stars and galaxies. So gravity is the force that pulls the apple to the ground, but it's also much more. It's a universal glue holding planets, stars, and galaxies together. It's the invisible hand that guides the cosmic dance of celestial bodies across the universe. It's a force that, although we can't see, we can certainly feel and observe in the world around us and the cosmos beyond. The concept of gravity has been around for centuries, but it was Sir Isaac Newton who first mathematically described it. As the story goes, Newton was sitting under an apple tree when an apple fell on his head. This seemingly mundane event sparked a profound realization. Newton wondered why the apple fell straight down, rather than sideways or upwards. He pondered why indeed it fell at all. Such musings led him to formulate his laws of motion and universal gravitation. Newton's first law of motion, often called the law of inertia, states that an object at rest will stay at rest, and an object in motion will stay in motion, unless acted upon by an external force. This law explains why the apple fell down towards the earth and not in any other direction. Going a step further, Newton's second law of motion tells us that the force acting on an object is equal to the mass of that object times its acceleration. This law helps us understand that a heavier apple would fall to the ground more quickly than a lighter one. But it was his law of universal gravitation that truly revolutionized our understanding of the natural world. This law states that every particle of matter in the universe attracts every other particle with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. In simpler terms, this means that the force of gravity decreases as objects get farther apart and increases as they get closer together or as their masses increase. Newton's laws were groundbreaking. They allowed us to understand and predict the motion of objects on Earth and in space. They explained why planets orbit the sun and why the moon orbits the Earth. They even enabled us to calculate the weight of the Earth itself. Newton's laws gave us a new understanding of the universe, but they were not the end of the story of gravity. Stay tuned as we delve deeper into the fascinating world of gravity and its role in shaping our universe. Enter Albert Einstein, who in the early 20th century turned Newton's understanding of gravity on its head. Einstein, the man with the wild hair and the brilliant mind, introduced a new perspective on gravity with his general theory of relativity. Instead of seeing gravity as a force pulling two objects together, as Newton did, Einstein pictured gravity quite differently. As per Einstein's theory, gravity is the result of the curvature of space-time caused by mass and energy. Think of space-time as a two-dimensional sheet. If you place a bowling ball in the middle, the sheet curves around it. That's the effect mass has on space-time. Now, if you roll a marble along the sheet, it will move towards the bowling ball, not because of some invisible force, but because of the curved path it has to follow. That's gravity, according to Einstein. This shift from force to curvature was monumental, and it didn't just remain a theory. Multiple experiments and observations over the years have confirmed Einstein's view. One such observation is gravitational lensing. When light from distant stars passes close to a massive object, such as a galaxy, the light doesn't travel in a straight line. Instead, it follows the curved space-time around the massive object, making the star appear in a different position than it actually is. This effect, first confirmed in a famous experiment during a solar eclipse in 1919, is a direct confirmation of Einstein's theory of relativity. So, while Newton's laws of gravity gave us a good start, it was Einstein who took us to the next level. His theory not only confirmed Newton's ideas, but also expanded upon them, offering a more comprehensive and nuanced understanding of how the universe works. Einstein's theory not only confirmed Newton's ideas, but also expanded upon them, giving us a deeper understanding of the universe and the role of gravity in it. Gravity is not just confined to Earth, it's a universal force shaping the cosmos. This invisible yet powerful force pulls together cosmic dust and gas, leading to the formation of stars and planets. Over billions of years, gravity has sculpted our universe into a vast expanse filled with galaxies, each containing billions of stars. Now, let's delve a little deeper. You've probably heard of gravitational fields, right? These are regions around a celestial object where other objects are pulled towards it. The stronger the gravitational field, the greater the pull. But here's where things get a little trippy. These gravitational fields can actually warp the fabric of space-time itself, a concept that's central to Einstein's theory of relativity. So, gravity doesn't just pull apples from trees, it shapes galaxies, guides the paths of planets, and bends the very fabric of the universe. Gravity, as we can see, is a key player in the cosmic theater, dictating the movements of celestial bodies and even the flow of time itself. Gravity, an invisible force, plays a fundamental role in our everyday lives and the vast universe beyond. We've journeyed through its discovery, delved into Einstein's theory of relativity, and witnessed its cosmic influence. This fundamental force shapes the universe, grounding us on Earth and orchestrating the celestial dance of planets. Yet gravity is a mystery still unfolding. With so much more to discover about the universe and its vast mysteries, make sure to subscribe to our channel. Together, we will continue to explore the intriguing complexities of the cosmos.